So let's look at solving some equations involving logarithmic functions. You can see this example here has the logs on both sides, and they both have the same base. Now, we haven't talked about this yet, but there's an extremely nice property which says that our next statement can just be the following, that x minus 8 is equal to 3x minus 28. It's a property, it's got to do with the one-to-one function, one-to-one property of logarithmic functions, not one that we've explored in any great detail, but let's just make a note. Why are we allowed to do this? If log base a of m equals log base a of n, then we are allowed to say that m equals n. So that's pretty handy in this situation, because then we can move all the x's to one side. I'm going to choose to move them to the right-hand side so my coefficient is positive, but that's a matter of personal preference. Then move the 28 over, so add 28 to both sides. You'll find that 2x is equal to 20, and then in a feat of mental arithmetic, x is equal to 10, so our solution set is 10. If you do a little mental check here, you get that now it is momentarily it looks like this one's going to be difficult to check, but if you just hang on for a sec, notice that if you put 10 in, you get log base 3 of 2 on the left-hand side, but then 3x minus 28 is also 2, so you get log base 3 of 2 on the right-hand side, and in fact it does check. So now I'm going to pause this for a minute and scroll down and write in our next equation. So let's take a look at our next example here. We're going to solve, I suppose I should write that in really, we're going to solve the following equation. Note it's log base 3 again, but instead of having log base 3 on the right-hand side, we only have a single number, which is 2. So the way to deal with this one is, again, we want to get the x out of the logarithm, and the way to do that is to rewrite this guy in exponential form. So the 1 minus x stays here, the 3 moves to the other side, and bumps the 2 up into the exponent. So then we get that 1 minus x is equal to 9. So negative x is equal to 8, and x equals negative 8. Let's just do a little check here. What is 1 minus a negative 8? 1 minus negative 8 is equal to 9. And the exponent on 3, so recall, so we've got the exponent on 3 here. What is log base 3 of 9? What exponent on 3 gives 9? The exponent is a square. So in fact we've got that 2 equals 2. So our check works here. Now I'm going to pause it again, scroll down, and write down our next equation. So here's the last equation of this set that we're going to solve. We'll do another set in just a little bit. But notice here that x is now the base of the logarithm, which means that there's going to be some restrictions on what legal values of x we're going to have. So we better have an x that is positive and that's not equal to 1, but let's not worry about that for the time being. Now again, because the base of the x is, our variable is buried within the logarithm, what we want to do is rewrite this sucker in exponential form in order to get the x out of the logarithm. So once again, the base of the logarithm, which is x, is going to go to the other side and bump the 3 up into the exponent. And then the question becomes, what, when cubed, gives 64? Or if you prefer, you can actually go one step further and say x is equal to the cube root of 64, but I hope that by inspection you can see that x is equal to 4. Now to check our answer, what we do is we take a look at log base 4 of 64. So saying that our x now is 4. What exponent on 4 gives 64? Why, that's 3, and so you can see that this guy works.